So good. So since there are all toolchain guys in this room, I don't have to explain why we need backtracing.
For the camera, please.
So yeah, there are basically two reasons C++ exceptions need backtracing when you throw an exception in C++, and all sorts of debugging tools that want just to display the call chain. It's backtracing.
Ramona should be.
So you don't, I don't think that you have to take just present, but maybe afterwards we have just got some discussions. I just pasted it into the IRC. Yeah.
We'll fix that up afterwards. Let's keep going.
Yeah. So in the old days we had ABIs with frame pointers, but nowadays no one wants to waste the register for this. So we have a special section usually that contains some information. On all other platforms, or most modern platforms, this is the EH frame section that contains dwarf informations to be able to unwind. But ARM is different for some reasons. Mainly, I think it's because of the size of the dwarf information. On ARM, we have the ARM exception index and exception table sections.
So, sorry. What are those two words that are in there for the function? So there's 8 bytes. So what type of information does the ARM exception table have?
We will get to this.
Okay.
So the index section basically contains a list of sorted key value pairs. The key is just an offset to the start address of a function, and the value can be one of the following 3 things. It could indicate that this frame can't be unwound. For example, if you got past main, it could hold a pointer to an exception table entry, or it could contain the table entry itself. So let's have a look how a table entry looks like. There are 2 different models to encode the data there. There's a generic model and the compact model. To my knowledge, GCC is only using the compact model. The generic model has a pointer to the personality routine, followed by the data of the personality routine, while the compact model has an index to one of 3 predefined personality routines, followed by the data of the personality routine.
So GCC will use personality functions of its own on occasion, but if it does, its data still is the same as for the compact model. So.
Okay.
And what is a personality function?
This is the routine that gets called in case of the C++ exception handler.
Yeah.
So it's function specific and it may do things like call destructors, that type of stuff.
Yes, so in the generic model, the data isn't specified. It could be anything. It's just a function pointer and some data. You don't know what's in there. Apparently, GCC uses the same instructions. I think I've got something on the next slide. So maybe that explains the questions. So there are 2 different formats, but that doesn't really matter. The data of the personality routine basically are instructions, unwind instructions. And in order to save space, what ARM did was, if the compact model is used in conjunction with the short frame unwind description, then you don't need the exception table section at all. It could all fit into the exception index entry.
So these instructions, are they ARM instructions or
No.
some type of virtual machine? Or
This is it's a limited instruction set. It's got push and pop instructions, and they also really care about size. For example, it's like the load multiple instructions, so you can load multiple registers using one instructions. So also using the unwind instructions.
So basically getting back to the question of why is there a function, the general idea is that in order to unwind, you go to a frame and then you call its function, the personality function, which is a routine that you can call, and that routine then understands its data. So the data can be anything, you just need to write a routine that understands it. But if you look at the whole thing from the outside, like from GDB, you don't want to run that routine. So you need to understand for the typically used personality routines what their data is.
Yeah.
And
So you
this
can
is
evaluate them without executing them.
exactly. And this is an instruction set for the three predefined personality routines.
Yep.
And this is what Uli just said. So you, from the current frame, you want to restore the contents of the previous frame, and therefore the unwind instructions. Okay. And this is where lib unwind comes into play, because usually you don't want to implement the parsing, the handling, the interpreting of the unwind functions yourself. You want to have this in the library. So the goal of lib unwind is that you can easily walk the stack frames without doing the work on yourself. You can access the contents of the registers, at least of some registers. Those are being Corley saved. And you could also resume execution at a certain stack frame. This is some lib unwind internals. It consists of several other libraries. It's not much of an interest here, I think. So let's see how this would look like in your code, just to give you an overview. Large enough?
Yep.
So this is really a simple test case. The main routine just sets up a signal handler called sighandler. The signal handler then makes some use of lib unwind. So this is the most simple example I could come up with.
So this is in process.
I'm sorry?
This is in process.
Yes.
Yep.
So first you need a context, and given that context you can initialize your current cursor, and with this cursor you could walk up the stack frame. And the function that gets to the next frame is called unwind step. In this case, I call a small helper routine called printrex. This shows how to access register contents of the next frame or the next few frames. So that's basically the simplest case. So if we just run this, we see that in the for loop, the print routine gets called and prints out the instruction pointer and the stack, and the program counter and the stack pointer. This is within glibc. This is the main again, and this is the foo that calls bar that calls I don't know.
It seems like a perfectly reasonable API.
Yeah. And one cool feature is that they could resume unwinding at the given cursor frame. So if we go up until this 5 was main, so 4 is the kill routine. So in this case, we shouldn't see the printf.
Yep.
Yep. So this is how it unwinds looks like. Good.
So that unwind resumes to where you created the context or something?
Exactly. So the context specifies.
No, I was just wondering whether this could work as some form of long jump or something.
Yes. Yep.
So it doesn't resume where you created the context, it resumed where he walked the cursor up to. So it walked the cursor back up to main, into the kill, I think, and then resume from there. So it's more flexible than set jump, but it can be used as a replacement for set jump.
In that case, you can even do a set register if you want. Why not?
I was going to say, how do you get, if you say you get a whole way around forcing a function to return somewhere in the way that it should have done, how does the return value work?
So what?
Yeah,
The return value of what?
Whatever function you just walk back up to, now looks like it's exited, right?
So register 0 is a scratch register. So in this case.
So you walk back up for stack and then you said resume. So this is a long jump. A function somewhere appears to have returned, but nobody's ever set return value.
Isn't that the effect you get with the long jump as well?
No, the long jump always returns from the set jump, which has a defined return value.
Well, the set jump here is the get context.
No. No.
The set jump is
Step.
when
Oh,
so
okay,
this
here.
will modify your cursor when you step up the frame. That will provide you a machine state, basically the contents of some registers.
So when you call set jump, the code enters the function set jump, and then it returns from set jump twice with a defined return value, which you know what you're doing. But in this case, you can effectively say, I want this, just delete this whole stack of functions, and the last one at the bottom returns, apparently, but with the whole of the processing not having happened. So I mean, is it just that you're supposed to know about this and only do it in case where it's saved? Or is there some way of choosing the return value? Question.
So if no signal frames are involved, then register 0 is not going to be changed, which means.
So maybe that's actually a bug. I don't know how that works.
Well, it's not a bug. I mean, if it's documented, then you just know not to return the functions that aren't expected to be.
Sure.
Exception destinations.
I mean, you're usually supposed to use and then resume only in the context of where you have exception stuff anyway, when it would go into something else.
I'm just curious to know whether there was a way of you could sort of stick a value in and it would pop out.
So what I had thought is that you could
Yes.
actually set registers and then those would be active, so you had to understand the API to some extent.
I mean, you could practically do it, just modify the cursor, but I'm not sure whether they have an API call for this.
Okay.
I could,
Right to
if it's of
save
interest, I
registers.
could just look it up. But
It's a topic for another time.
okay,
So yeah, it's valid. You resume here, and the original caller may get a random return value.
But I mean, obviously, this is documented. You know this is a function that can return from an exception. Yeah. It's not a bug. It's just.
okay. So this is a collection of things that we achieved in the last few months. So we've got the support for lookup, extracting, and decoding the entries from the specific unwinds table information.
Okay.
Yeah.
Maybe as long as you have the demo there, maybe you could just do a read of the schedule on the main, just so we could show a couple of those instructions. That's how it looks like.
Oh, so it decodes them.
Yes.
Yeah.
That's quite nice.
But that's a recent feature that was added, I don't know, a
Yeah,
few
it was
months.
recently added and was a little bit buggy and that's been fixed very recently. So
There's another way you can do it, which looks very different.
that's one I know of.
Okay. So, so the basic support for decoding these sections is there. Currently, Unwind also supports you to have a stack that's mixed, that where one stack frame is described using dwarf information, and the next stack frame is described using the exception table frame information. So this is working. The most recent feature was the ARM signal frame detection and handling, and then the resuming support to resume the stack frame. Yeah, besides this, there were a lot of build, code, and test suite fixes we made. The good thing is that all of this is now upstream, so the repository that is on my repository, my Git repository on Linaro has no additional changes compared to the Unwind, so this is all in. But still, these are the things I have in mind that needs to be fixed, or that would be cool to have this in place, because there are some corner cases where it would actually fail. For example, if floating point registers are involved, these are currently not safe. So I'm only focusing on the R0 to R15. So this needs to be implemented. I think this is straightforward, but I haven't really looked into it yet because I was busy with the other stuff. Also, I haven't looked at the support for remote unwinding. Unwind supports to unwind remote processes, but also foreign architectures. That's a little bit fuzzy, and I haven't really looked into it, but that may be worth to look into. I don't know.
Version 2.
And then there's when you build libunwind on x86 and you want to use remote unwinding with ARM, then you need to have some header files in place that describe some data structures. And I think the way that libunwind circumvents from having you all the header files from all the targets that libunwind supports to be installed, it just hard codes some offsets into having a special header file. So this would be something that's currently missing, but this is somehow tied to the remote stuff.
So which of these features are needed for native ARM in-process unwinding on current systems?
The last two bullets. So currently, the unwind only understands dwarf only, if at all. I think I had a quick look with Uli into this, and it turned out that their dwarf parser is very limited, and this is nothing ARM specific. This is generic, but no one seems to care. And if you use a recent GCC that does sophisticated things, when whatever something is inline, also. This is then dwarf 3, 4, whatever.
Yeah, basically the dwarf call frame information, which is a similar sort of bytecode, if you will, but it's just completely different in the details. But it's also sort of a language, and that has been extended over time. And what libunwind seems to be implementing is basically the dwarf 2 standard. And in the meantime, we got dwarf 3, and now we got dwarf 4, and people are already extending beyond that. And current GCCs are actually generating some of the information if you tell it to with the proper gdwarf 4, whatever option. And
and parsing dwarf isn't trivial either. So
and that's not minor changes, but that's sort of more fundamental changes. Like in dwarf 2, you could only describe a register lives at a location. That's all. It had to be somewhere in memory. And now you can say, I don't know, it doesn't live at any particular location, but I can recompute its value by adding stuff or confirming complex operations or whatnot on it, or on some other stuff.
Huh. So as in, stack pointer based or...
Yeah.
So this really requires deep understanding of dwarf internals. So that's really a huge thing, I think, to have properly implemented. And then currently the thumb marker isn't handled properly. So if you print out in the example the addresses, thumb marker is in there, I think. If you compare these values to GDB, they are slightly different by the marker.
That
And-
means that cross thumb interval resume probably sometimes doesn't work.
Yeah. So this is something that needs to be worked on, and yeah.
Uh-huh.
Does any of our ARM configs currently use the dwarf CFRs?
Excuse me?
For debug information, well, all the debug, so if you compile with debug, the debug frame section always contains dwarf CFI. It's just, we don't get the EH frame.
So on ARM, the EX tabs replaces the EH frames.
Yes. And the debug frame stays as it is and stays dwarf. And that's why, if you have it, it's better to use that because it's more precise than.
Yeah.
So for the next cycle, the idea was to just grab one tool that needs backtracing and implement it, and to just show, okay, here's something that works, and find out the areas where where we need to improve.
Do you have any performance numbers? How many 20 deep stack frames can I decode per second?
No, this is all about correctness.
Yep.
I haven't started profiling the unwind. I think I could improve the performance by doing some caching. The problem with caching is when something gets loaded dynamically, so I'm not sure.
Multi-threaded aspects. Because
Yeah. So no, I haven't benchmarked it yet because I was focusing on correctness. Why are you concerned? Well, I mean, I see that it would be a nice thing to have it really fast, but in my opinion, this is something that doesn't occur very often and should. And if it occurs, but maybe I'm wrong on this.
That depends. I mean, there are very important use cases in use of this for crash debugging,
Yes.
where performance is not an issue at all.
yes.
But there are other use cases like if you do profiling and every sample tick you want to create a backtrace, where was I?
Mm-hmm.
That's what perf does in some modes.
And-
Then you need the backtracing to be fast.
So
Yes.
that's an interesting thing. So yeah.
We then have to make an overall change that if exceptions is on by default.
Yes, that
Yeah,
is
and that's a
probably
whole-
one of the important things we need to discuss
Yes.
now.
That's,
Yep. So all of that leads towards what should we do the next cycle to make backtracing on ARM work. I'm going to use the word pervasively. I haven't used it in ages. Pervasively available. So, crash dumping, profiling. Those are really the two main ones.
so
Do you have some more chance on that, or should we just discuss it?
no, I think that's just. So the presentation is just finished.
So from what I'm seeing is there's two problems with actually doing that what I just mentioned, which is having perf at every sample tick to create a backtrace. And the one is if we don't have debug, well, you cannot use debug information, the dwarf frame from perf, because it's not in memory, it's just on disk. You can't get perf to read files at a sample tick, it's just not working. So you have to have something in memory. So we don't have EH frame. We do have the ARM sections, the exception table sections, but only for code that uses exceptions, which most C code does not.
Can you bring in the blueprint, Ken? Because I think this is good discussion. I think we've got most of this in the blueprint, so I'd like to talk
Okay.
about
Just so
the
that we
blueprint
can-
as well.
So I was trying to say the first problem is that, as you said, this is not there at all, which could be enabled by having, let's say, unbind tables default GCC option. But the second problem is even if you do that, the ARMX table is still not precise enough to be used at random sample ticks because it's only guaranteed to be correct at function call sites and not at any random instruction boundary.
So what's under the work items?
Sorry,
Yeah.
you're saying that the unbinding equation is not accurate at any point.
Yeah.
That
It's
is
only
that's half true. That's only half true. GCC tends to, I forget which comes first, but it's accurate, but not necessarily exactly the same byte. It tends to aggregate multiples, reads and writes.
No.
But it doesn't just say at this call site this is the answer. It does it
No.
on a per instruction basis.
Now for the ARM exception table, you get one per function.
No, this isn't the same as the unwind table. This isn't the same as the frame.
On ARM. So on all other platforms, if you say F unwind tables, you get dwarf. And if you get dwarf, you have per instruction. Precise thing. But on ARM, if you say you get the ARM X table, and there you get one per function. And that's it.
And the other thing is that the linker
Laptop,
can
bring up the
end up
blueprint and, just
combining things
Yeah,
together
yeah, yeah.
and create a larger
Do you want to-
thing.
Yeah, that's fair. That's okay as long as it's precise. But if
That's the reason that the linker has been changed so that it doesn't do the merge for backtrace in Java.
Do you have to look in first?
yeah,
Because-
Isn't it supposed to be
It's
entries?
no one, the Java backtrace doesn't go interpreting the entire thing. It just looks at the PC and says, oh, this is where the unwind table starts in this block. And that could be the previous function in this.
yes.
And that's the reason
No.
that the
No.
merging fails.
And that's another fundamental problem actually with the data structure, because the data structure just says start address value,
no?
Yeah.
next start address value. It has no links or entries. So it's implicitly assumed to be valid until the next entry, which may be wrong if in the meantime, in the middle, there is a function that had no information at all to start with. So that gets just merged in.
Yep.
There was some discussion that this could be fixed on linker maybe, but it's not.
So maybe sledgehammer solutions transition ARM
So one question would be whether we want within Linaro for our Linaro build to add unwind tables to the default flags to be able to unwind. That comes with a cost.
That
For
comes
sure.
with two costs. One is the extra cost in terms of disk space.
Yep.
I'm not too worried about space that it might take in memory. Unless it's used, it's demand page. We don't care about any extra memory footprint. That's not going to happen.
Okay, this is a problem I have for.
Your zip keys in the
that
right
is-
place. Where the hell should
And that was
Here it is.
unwind tables as default.
Yes. So I have actually, we have some experience with exactly that same question. What we did on 390 many years ago, we decided to switch on actually an asynchronous unwind table by default. Okay, and that creates dwarf, which is bigger than the ARM stuff, and it creates the asynchronous version, which is exactly every instruction, so it's again bigger.
It's even bigger.
Yeah. And we did that, and we were very concerned about this disk space issue, and so we did it on our whole internal distribution, measured it, and I think we came up with about 9% increase in disk space, something like that.
And this was with Dwarf, while
This
the
was
compact model
Yes.
of the ARM specific unwind tables should be smaller than that.
So that's
So-
certainly an upper bound, but for things what you can expect.
So how about, in terms of actions, add F unwind to example set packages, document the overhead plain ARM and also dwarf on top.
Yes.
I think there's some, there might be some research inside around the time when the unwind tables were designed. So maybe I can see what's.
That would be interesting.
So is there, I mean, obviously the way the unwind jumps are defined today, it will not solve the asynchronous problem. So just get an example.
That's not going to be a.
Is that, I mean, has that been discussed at all, or is that even a requirement that is considered valid, or is it?
Did they have this point in mind when they designed it?
No, the original unwind tables were designed for embedded systems, where you wanted a very light exception tables with C++. People were concerned about the ROM footprint an image was taking.
Yeah.
And this 10%, or let's assume, given that we have this number of 10% between the async, no, let's leave asynchronous aside. A sizable difference in size, pretty big difference in size was thought to be, I think the OEMs would have thought it was too costly. So I think that's the only explanation I can retrofit on that.
Am I allowed to use throw from within a signal handler? Is there anything that prevents me from doing?
I think that's doable. That's one function now.
Throw the C++, so throw an exception
From signal handling.
Well, C++ says no, but GCC allows it in some situations if you have built with non-call exceptions or which requires dwarf to work because of exactly that feature.
Okay.
And it's used, I think, only by Java, nobody.
And non-call exceptions occur a
Unless you
small
have-
potential performance degrading because it adds some scheduling barriers before the block roll off.
Yes.
But usually you don't consider it if you're on the exception part. It's not considered to be a part in your application.
Now the problem is if you say, I want every single instruction to be ready to receive an exception. If I got a signal there, I could have gotten a signal on any random instruction.
Yep.
And that signal handler might have thrown and it gets me back up there.
Mhm.
So any potential instruction must be ready sort of to as a restartable place. And that includes restrictions on what the scheduler can do.
When you say exceptions, does that include breakpoints?
No.
When you're talking about DC information,
get used to stuff.
No. So we were talking about a C++ type throw out of a signal handler.
I know, but we were talking about general unwinding and stuff, and the debugger needs to know these things as well. I was wondering whether that was the same problem.
Yes, of course. A debugger also. Ideally, I have exact unwind information at every step. But in the debugger, I can. DB does weird stuff anyway. In the debugger, I'll fall back to prolog parsing and whatnot.
Okay, so it's all programmation.
Yeah.
So, how about these in terms of statements? We want to qualify things, so let's see how big a selection of packages get if we turn that on. Let's see how big it gets if we turn on dwarf 2. How about this for a statement? A crash tool should always work on any installation. A profiling tool only needs to work on a developer's installation, so they can install the dwarf information alongside. But it's
Okay.
not in memory, is it?
Yes,
Yeah.
that's the problem. On ARM today, there's no way to get dwarf CFI in memory. You can only get it on disk copy, and that's not good enough for perf.
And what do we do to change that?
That's an ABI issue.
it's an ABI issue, fundamentally.
When you load your program, can you tell the loader also load dwarf?
This is an option.
So let's say the end user for profiling is a developer, and mildly nasty things are okay. Is there a fairly direct, mildly nasty solution?
So, I mean, it's not so easy because what does load in memory mean? So, it's not enough. It's not enough just getting the part of the alpha map. That's the one thing. The other thing is the consumer needs to be able to find it. In all the shared libraries that are there, all have their own little parts of the table, and the unbinder needs to find all. So for the EH frame, there is a mechanism. It gets put in by the linker in a specific part of the dynamic section, which the LDSO collects all together, and there's an interface to just get all of them. And all of that works with EH frame.
So I think if you want to make something,
and the two of them are quite different. Even though they are similar, there are differences in the layout.
Sounds like the best put it is the edge frame.
So I guess
Indeed.
So I guess the question is, can we say as an ARM ABI variant, we just do EH frame anyway?
Maybe the idea to take back or to propose is, can we propose this for V7A or the Linux ABI? Is that
The blue part of the ABI turned into EH frame.
can we propose that?
Yeah.
That's the problem is it brings a break in the architecture, I don't know. Because some people who are using V5 will suddenly scream because we've just increased the size.
I'm totally lost track of this stuff. Can someone please summarize what we've actually decided on whatever so I can write down?
We haven't decided anything, this is still discussing.
there's a fundamental.
I think we have decided one thing, which is we do want good crash routing, and we can do that using the small exception tables, but we have to prove that it's valid, prove that it's not a burden.
So for crash information, the existing ARM exception table should be mostly good. Unless you just are unlucky enough that you crash during the prologue because of a stack overflow or something, then you're lost.
But on ARM, isn't the program usually quite small using the load multiple or?
Yes, but if one of those instructions crashes, say because the stack overflows, and you just write to stack that song over there.
Yeah, I see.
Yeah.
There's nothing.
Richard, you want to?
Yeah, it's very that question, but I mean, does it go to remind information of this sort of confession thing of being able to share FPEs between CIAs if they're identical?
Yes.
Which happens, I suppose, for a lot of functions, normal functions that don't throw exceptions or such like.
But it's,
So I just wondered if, you know, if you actually had this information per function, would dwarf to actually be almost as good as the, or as compact as the ARM version?
no, I don't think so, because the index entry could point several times to the same table entry. So you've got the same mechanism there, plus the compressed.
So just as a quick feel, the total size of the information described for one function can in many cases be 4 byte now.
Okay.
So and dwarf even the header is 20 byte or whatnot before you even start doing any data.
Okay.
Anyway,
So there's-
if you turn on shrink wrapping, it's totally different.
Yes.
So, crash tool using ARM exceptions tables will work, maybe will fail 1 time out of 10 when you're in the prologue.
If I may revert my previous opinion, that since Andrew just pointed out that we now have the shrink wrap optimization, which means that if it crashes anywhere in the part that's outside of the shrink wrap, you also won't get correct information.
So any of the early exit code before the shrink wrap. So you can't have anything that causes exception in the early exit code?
I mean, we really exit typically if something, and if,
Yeah,
if
we've not
something accesses a null pointer, crashes.
Yes. It will probably come as a result, it will probably, yeah, it will be a bit confused.
Well, if you had dwarf, you would just know from the
Yeah, yeah.
PC, but if you don't.
Yeah, with the network, ARM mix.
With ARM, there's just one per function, and it assumes that all the function looks the same across the function. It just isn't true.
So I think if we are going to stick with the ARM exception table, there are some corner cases. The question is, are they likely to happen?
If we have a crash reporting tool today versus with libunwind, what percentage more crashes are we going to be able to backtrace? Currently, I guess it's really 0.
Yes, I think if you don't build with F unwind tables and you don't have any dwarf information, then you can't do backtracing. You can apply some heuristics, but I think that's
Have we got some feedback from some of those that rely on these crash dumps? I mean, I know that all the big applications like Mozilla and OpenOffice and whatnot, they all have their own infrastructure.
also
to
this
do
was
that.
actually this is what I'm going to ask you. What would be the tool where you see this would be nice to have backtrace capabilities there? So because I'm having a hard time come up with something that would be.
I guess
really
that's
useful.
another of the more fundamental questions. There are existing users of the crash backtrace capability out there, and not a single one of them, to my knowledge, uses libunwind.
Yep.
They all do their own stuff.
Yep. And
So that's the reason for switching to lib something, so that you can pass it off into a common library.
So you're going to convince Mozilla to throw away their own crash backtrace handler and use libunwind?
It's probably not
Well,
not
the-
that I don't want, it's just so much work.
Already they're going to have an architecture-specific backend. They're going to have their own unwinding API. If that is direct calls into libunwind that they stub out, I think you could justify that. I mean, it is an extra build dependency, it is an external dependency, but
and for if you only want to do backtracing, there's also the glibc backtrace functionality. So
Yes, but that's usually insufficient because it doesn't show any parameters and it doesn't.
yeah, the unwind also don't show parameters right now.
so how does the glibc backtracing work without having exception tables?
Not.
It doesn't.
It depends a little bit. So the glibc backtrace, the history is it used to follow frame pointers on the platforms that have them.
Yeah.
And since these days most platforms don't have any frame pointers anymore, what they do is actually the glibc backtrace calls into the libgcc backtrace, which is the same that is used for exception handling. So it's exactly the same.
Sure.
It works exactly in those scenarios where exception handling will work.
Which is at the moment none, because if exceptions is turned off.
On our own, yes.
So that, yeah. So at the moment this is looking like a wish list, and some of them may be knocked off and give positive improvements, but some of them may just not be justifiable. So need to decide on a crash dump tool, something that will benefit from a crash dump. So Ubuntu has one built into it for general crash recording. There's Firefox, which is probably a bit of a pain if you wanted to exercise things against. But there was that keynote today, him standing up saying Ubuntu doesn't know when things, the most common causes of
Yeah,
crash.
that's what I found interesting, because he was basically saying, well, we have this great crash tool in Ubuntu, and it does all kinds of stuff, but every time we put out a release, we switch it off, because we don't have any location to send the reports to.
So
Nobody would
it
develop
sounds,
them.
yeah.
So hooking into the Ubuntu crash tool may be interesting then. Because it'll be self-contained as opposed to Firefox, which will be large.
I must have a bit of no idea how the generic Ubuntu crash tool works. I don't know what it is.
Me neither, but it is considered to be important, and we should have a look at it.
Yeah, sure.
So I think something to put in the notes is we need a crash tool to demonstrate this out and to talk with Ubuntu and find out what they use, and to also investigate Firefox and see if it's ridiculous or not. If it's got a 10-minute build cycle, then it's no good for developing against.
So, I mean, and in the end, to make really significant progress, we obviously have, it has to be some sort of more systemic change at the ABI level or whatnot. And so I'm wondering, I mean, there's obviously reasons why ARM did the ABI the way they did it. On the other hand, I would expect having good crash reporting capabilities also these days should be a very high priority for ARM customers, shouldn't it? So
there is some, yeah, there are some queries about even good crash reporting as well as backtracing profiling samples.
yeah.
So yes, it is being discussed at the minute, but there is no one answer yet, unfortunately. But this is good information. I'm going to take this back.
Okay.
Do we have any stories about where this is being used in real life with S390, for instance, in production?
Yes, but S390 is not any, I mean, we use it.
No,
on
it's
Linux, but
in
not,
the Linux thing. I just
it's not special. I mean, on 390 we just basically do the same as on Intel, but it is extremely important because, I mean, on 390 with enterprise customers, you must have crash. You must, I mean, you can never say to a customer, system crash, and I cannot tell you anything about why. That's just not acceptable in that space. So we must be able to analyze crash counts, and so therefore that was crucially important for 390. And that's why we did it. We accepted the extra cost and space, and so far it's working for us. But it's not that because we did anything more than others, we just at the same level as say Intel or platforms.
So one possible small step for us would be to just say, okay, for our Linaro build, the thing that we are providing, we enable F-online tables. There are still some corner cases where it won't work, but maybe after we prove that, okay, the overhead is so big.
Well, you will really know that by building a flavor and seeing what the overhead is.
Yep.
There is no other
So
way.
that's, I think, one of the next steps.
One of the next steps should be to investigate the overhead.
Yes.
So if it turns out to be a 1 or 2% increase in overall package size, so including data and everything else, I think that will be fine. And if the upper limit with async exceptions on your architecture was 9% on the binary, then it's feasible, it's conceivable that it will be a small overhead. So I've got down there, add F unwind to an example set of packages and document the overhead of both.
It's F unwind dash tables.
Yeah, but that doesn't matter.
Yeah.
Michael has a hard time with my German keyboard, so.
If I had a craft knife on me, I'd fix your Z and your Y keys because they're in the wrong places. It's this dodgy IBM stuff that they're using. So I've split the profiling work items out into a second stage just to keep them separate. And I've made this very dangerous statement, this very long work item, which is proposed changes to make profiling possible. So, you know, obviously this is a big discussion, but from what I've heard here, it sounds like on a developer system where you can afford the disk space for dwarf information, there may be some changes, some reasonable changes, so that those can be used for sampling-based backtracing. But it is an API change.
It is a pretty big area.
So I mean, I guess depending on what kind of compatibility you want to guarantee, we could sort of have both. the ARM table and EH frame. It's and continue to use the ARM tables for exception handling and use the other one just for backtracing.
Use the other one for backtracing and maybe even use it for
If we have EH frames, then why should we want to use
Yes, you're right. Of course, we could use it for those we had them, but let's say we have for one function, for the next function, we just have the ARM table. We would still not just fail, but then
you
use the
use
ARM.
the PHP.
Sorry, I've got another meeting, but I'll give you that. It's
you.
good discussion. I'll leave you to it.
Upstreaming, I have one question. So can you check the meeting note? Just kind of my question. Meeting note, I mean.
Which one?
Etherpad.
Etherpad. Oh. Where is it?
I have some feedback about Android.
Oh, yeah, well,
Oh, Android is another interesting use case.
Yeah.
I'm assuming that Android is also interested in tertiary polygon.
Yeah, because Android has a tool like called debug D. So can you see the purple? Oh, the font is so small.
Where's your question? Sorry.
I just
This one?
yeah, the purple one. So there is a copy of lib unwind in Android. And there is a tool called debug D, which is a debug daemon. So the working model is debug D runs as a service, and Android's linker has a hack, which reaches the signal to a function which talk to debug D. So if a program crash, the linker talk to debug D to dump the stack. So you can see the track tool. Vicky, can you?
This
Yeah,
one?
Yeah, this one. So the tool is very powerful. Every time the Android program crash, the debug D will dump. Use ptrace and lib unwind.
Okay. And I'm assuming that the debugger D will use dwarf information from disk.
Yeah, yes. My question is, Android engineer include a very old version of lib unwind. Is it possible for Linaro to submit some patches? And if it's possible, what is the copyright?
I'm not aware that the license of lib unwind has changed. Let me.
Is it some BSD or BSD license?
Yeah, because and there should be Apache license, but not really. Really not the copyright. Because
It's. I thought it was GPL.
If it's GPL, then not many will use it.
Yeah, but if they are using it right now, then
Then they might not be.
Yeah.
No.
Yeah, so there is no problem if
Okay,
want
this
to
looks
submit,
good.
right?
Well, if you submitted it upstream, then all you have to do is prompt them to do another pull or something.
yeah. So I think we could look into that if Android is considered to be important. And my understanding is that we will have Pandaboard Android images soon to play with.
Yeah.
Because I
Pandaboard is
would
ready.
need a development environment for this.
You can check LAB. LAB support Pandaboard now. So I think it's an interesting topic if we can support updated change for Android codecs.
Okay, so all BSD style license. Okay.
I personally think, can you check the tool?
This one?
Yeah, this one. So I think that there is a room for improvement. At least we can show more information like front door or to print the whole stack once at the pushing crashes.
So, what are these? This is.
You can scroll the browser, scroll down. You can use external tool to figure out. Yeah. Yeah. I think that if we can improve it, but more and more developers can benefit from this.
So this is then something like an ELF reader that builds a simple table and then maps the addresses to the functions.
Yeah.
So if you go to all the trouble to call an external tool that can read from disk and whatnot,
And it
why
could use
would that
GDB.
external tool not simply be GDB and do a backtrace? We have everything with parameters and all you could want.
Why not generate a code file and
Yep.
Or just generate, yeah.
Why
if
not?
you can.
Well, yeah, so the problem with core files, I guess, on Android, what do you do with a core file on the
Where do you
phone?
put it?
Where do you put it and where do you get it anywhere?
Do you know if Android is using a different API?
It should be the same.
So they're following the
No,
glue.
but they must be using this on
The old,
in ADP.
the-
They would be using this on the host.
And it's
The
separate
Python thing must be on.
Yeah, but we want, this is for crash reporting, when it regular use, when something crashes, and you want to right now, generate a report.
transmitted wireless.
And I want to highlight the importance of debugging, because in Android you have to debug Java, debug C library, and
Yep, yep.
debug virtual machine, because everything can crash.
But having core file support would be cool, even if we have another tool that's using unwind. But for real debugging, GD is the best you can get.
Yeah. But in Android, it's hard to use GDB to attach every process, because every Java program it uses the time activity is standalone dedicated VM process. So there are many processes, and the framework is very large. So you cannot use. It's hard to use GDB because you even don't know which process to attach. There are many standalone processes.
Yes, but if you get this tool that is called back
Yeah.
and gets triggered, now do something, this could invoke GDB on the right process.
Yeah. I think that integrate GDB is an interesting feature, and it should be
Yeah.
feasible.
I'm not sure when we've got the time to look into this, but depending on the priority, I mean.
But I think if we are using for a use case that is important, that is actually going to get used,
Yep.
I mean, Android is certainly should be higher on the list, I would say.
Yep. So I think I will discuss this with Michael in one of the next meetings, and maybe he will bring this to the TSC, or whoever decides what is the most important things, because due to limited resources we can't do all of this. We can't even implement this what we already got. So.
At least it's a great.
And any help is welcome. So. Okay, good. So thanks for your input. And if you